Hello everyone, I am ATUL NEGI and I welcome you all in this IMS Academy YouTube platform. So we have started our foundation course on theory of machine and we have started our chapter first, that is symbol mechanism. In today's session we will be discussing the kinematic analysis of single slider crank mechanism. Okay, we already discussed about the mechanism, we have already discussed about the basic building block of the mechanism, that is link. We have talked about link connection, that is kinematic joint or kinematic pair. Then we have talked about kinematic chain as well, and then finally mechanism and also inversions. So all theoretical fundamental things we have discussed in details in the previous lectures, and in the last class only we have discussed the velocity analysis and acceleration analysis in detail, and we have solved previous year gate questions also, right? So if you have not watched those previous lecture, please first check velocity analysis, in which we have discussed two methods, velocity diagram, second eye center approach. So both the methods we have discussed in detail and all PYQs we have done in the class itself, right? So if you have not watched previous lectures, please watch those lectures first, because that is a very important part in the gate examination. Every year question is coming from the velocity analysis part, right? So in today's session, as I told you, kinematic analysis we will be discussing, and in the second section, hi Matan, very good evening. In the second session, we will be having a dynamic analysis of single slider crank mechanism, right? So let's get started everyone. And there is an important information that you can join this Telegram group for having all the updates regarding recruitment notifications, as well as all our YouTube events that we are doing in the Gate Academy, IMS Gate Academy YouTube channel, right? And daily quizzes are there which will definitely help you in your gate preparation part. So for that you can directly join this Telegram group, and all lecture PDF will be available in this particular Telegram group. Now next, as I already informed you earlier also, we have started our live online program, and in that live online program you will be getting more than 800 hours of live interactive classes. Interactive classes means what? You can directly interact with the faculty in the class itself, right? And apart from that, all theory books, exercise book and gate previous year book you will be getting. And most importantly, one-to-one mentorship sessions you will be getting, where you can directly discuss your concerns or whatever problems you are facing in your gate preparation. One-to-one you can directly discuss with the faculties who is teaching you all the subjects in the gate examination, right? And finally, doubt solving portal is always available, and apart from online test series starting from chapter level, subject level, multi-subject and then full length test. So these are the features available, and if you want to join IMS Gate Academy live online program, you can directly call on this number, and by doing so you will be getting you will get in touch with our IMS Gate Academy counselors, and they will tell you all the process and how to enroll in this live online program, right? Okay, so we'll start our session on the velocity analysis of kinematic analysis of basically single slider crank mechanism. Now as I already discussed multiple times that kinematics will be the very first part that we'll be discussing before the dynamics. And what was the logic that why we are starting with the kinematic analysis, not directly with dynamic? So kinematic analysis means we will be discussing the motion. We will be having a discussion only on motion. We are not concerned about how that particular motion is happening in the system. Okay, as already we know that there will be some forces because of which only the motion is happening. But we are concerned about motion, and the reason is because once we have done the motion analysis, then only we will be able to calculate the forces associated with that. Without doing any analysis of motion, you can't calculate the forces. So force calculation requires this kinematic analysis. That's why kinematic analysis will be done first, okay, instead of directly doing dynamic analysis, right? So in kinematic analysis, most important part is the position. Okay, once you have understood the position, then you can talk about the displacement part. And once displacement part is done, you can easily discuss the velocity. Velocity analysis we can do. And when velocity is done, we can talk about the acceleration part also. So this is the sequence, this is the order in which our analysis will be there. So starting with position, then displacement, then velocity and then acceleration. This will be our order of analysis. Now Once it is done, then we can go for dynamic analysis. As I told you, force from the Newton's second law equals to mass into acceleration. So without acceleration, you cannot calculate the force, right? So that's why in order to calculate acceleration, we need to know about velocity. And for velocity, we need to know about displacement. And for displacement, position has to be clear. Okay, so that is what the sequence of discussions that we'll be having in kinematic analysis of single slider crank mechanism. Single slider crank mechanism is most important mechanism in our gate syllabus part, right? And I've told you also the inversions. All the inversions we have discussed previously in the lectures, right? You can watch those lectures also where we have talked about all the inversions. The very common inversion that we are having is, which is what used in IC engines, reciprocating compressors. Apart from that, crank slotted quick return motion mechanism, Whitworth quick return motion mechanism. So many mechanisms we have discussed, right? Okay, so this will be the our analysis. Okay, this part we will be discussing in the analysis. So first of all, we'll start with the kinematic analysis. Okay, so let's suppose this is our single slider crank mechanism. Now let us mention all the members here. Okay, let me mention all the members. Okay, so let's suppose the namings I will give here. Let's suppose this point is A, and okay, one more thing here. Inner dead center, this is IDC, inner dead center, and this is outer dead center, ODC. Okay, IDC and ODC, inner dead center, outer dead center, right? Now, so this is point A, and let's suppose this is point B, and this point is O, right? Now, so what is in this particular diagram we can understand? Okay, from this particular diagram we can understand that from IDC the piston has moved, or the slider has moved by this X distance. Okay, this is what the distance or displacement of this particular slider, right? So this is what the displacement of the slider for theta angle rotation of the crank. For theta angle of the crank, this much displacement you will observe in the slider, right? So always understand, this much rotation happens in the crank and the slider moves from IDC, and how much displacement it has done? X distance for this theta rotation of the crank. Okay, so let me just mention all the names here. This is our crank, right? This is connecting rod, right? This is our slider, or you can call also as this one as piston. Okay, this is our cylinder which is fixed in this case, right? So motion of a slider started from point B. Motion of a slider started from point B and it reaches to point A. And how much distance displacement it has done? X for theta rotation. Now it's done. How I can write this X distance in terms of this theta? In terms of this theta. That is what very important. Because I want to relate the displacement of slider with the rotation of the crank. And why is it so? Why it is important? Because the motion, input motion, let's suppose if it is a case of IC engine, I am providing input motion to slider, output motion I am getting at the crank, obviously. So input and output motion should be connected, right? It should be related. For that we need to have a proper relation here. Or if it is a reciprocating compressor, so whatever rotation you have provided to the crank, based on that slider will be going to move. So that theta relation should be there with respect to X. Okay, so that's why our intention here in kinematic analysis is what to relate this X displacement with this theta, right? So if we have done that, we can easily calculate velocity of this slider, acceleration of the slider. And if you see previous year gate examination, there are a lot of question has been asked from the velocity of a slider, acceleration of slider, right? So there has been lot of question asked from that part. So intention, the purpose also, it should be clear here. While discussing any topic, what is the purpose? Why we are discussing it? Okay, so purpose is we want to relate this input motion and output motion. Input motion means the displacement of the slider. Output motion means rotation of the crank. For the case of IC engine, if it is reciprocating, reverse will happen. Input is provided at crank and input provided at the crank for reciprocating compressors, and output you are getting at slider, right? So this is what the basic information we should be having. Now, after that basic calculation we need to do. And one more thing, just write down crank we will mention by R and connecting rod by L. Okay. Now, few things like N is the ratio of connecting rod length divided by the crank radius. Wherever I will find L by R, I will mention it with N, right? Okay. Now see everyone. So basically, one more point that we need to remember here is this stroke. Stroke is what the movement of your slider from IDC to ODC. The movement of your slider from IDC to ODC is known as what? The stroke, and that stroke will be equals to twice of the crank radius, 2r. This relation you have to remember, right? Clear? So twice of crank radius will be equals to stroke. Stroke is nothing but the distance between IDC and ODC, because between this IDC and ODC only your slider is going to reciprocate. It is going to reciprocate between IDC and ODC. Right, so distance between IDC and ODC is nothing but 2r, that is what the stroke we are having. Okay, fine. Now, I want to have this x value in terms of theta. Okay, so x, first of all, this displacement of a slider can be written as total OB distance if I subtract. Okay, if I subtract OB distance, okay, this is the total distance OB. From this OB distance, if I subtract OA, right, so please observe this part, very important, OB minus OA I have written here. Total distance from OB if I subtract OA, this is what I will be getting, right? So from point O to B, whatever the distance is there, from this distance if I subtract OA, I will be getting this x value. Okay, that is what the displacement of the slider. Now, that OB distance, this OB distance is nothing but L plus R. L plus R. L is the connecting rod length, R is the crank radius. So when it is having 0 degree angle, that is 0 degree theta. Theta value is, let's suppose, 0 degree. In that case, what will happen? Crank will be like in a horizontal position, connecting rod will also be in a horizontal position, right? And that complete distance O to B will be L plus R. Okay, this is very important aspect of single slider crank mechanism that we need to remember, right? Okay, so that OB we have written, but how to write OA distance? Okay, so for this one, let us consider, okay, let us consider this angle as beta. Let's suppose this angle is beta. In that case, what we can do, let's suppose from here one perpendicular line I have drawn. So this distance will be known as L cos beta and this is known as R cos theta, right? So we can write here L cos beta plus R cos theta, right? This is the value of x. That is what the displacement. Now the problem here in this particular relation is we have two angles. One angle is the rotation of crank, another angle is for the connecting rod. So as I told you initially in the analysis part that I want the relation between this x and theta only. It means I will have to replace this beta in terms of theta. I have to replace this beta in terms of theta, right? Because I simply want the relation of this displacement of slider in terms of rotation of the crank. That is what two variables should be there in my relation, not any other variable like beta. Okay, so that beta is not important for me, right? Now, so what I will do, I will replace beta. So how we can do that? See, if I take the vertical component of R, it will be R sin theta, and in a similar way L sin beta, both the vertical components will remain equal. That is what this vertical component I am talking about. This vertical component of R and also L will be equal, Okay, so that is what we'll be using here. So L sine beta equals to R sine theta. This is the relation that we are going to use. Very, very important, right? Fine. So this relation I will be using. So let us write it in the next slide. So sine beta value can be written as sine theta. Sine beta equals to sine theta. Okay, sine theta. R is already there in the denominator, L is there. Okay, L will come finally. Right. So as I already told you initially that L by R is nothing but N. Okay. L by R can be represented as N. Wherever I will see L by R, I will represent with N. Okay. Just to simplify the equation part. That's all. Okay. So N is nothing but the ratio of connecting rod length divided by the crank radius. So sine beta value is equals to sine theta divided by N. Okay, fine. So this is what important relation for us. Okay. Now, but in the equation it is cos beta. So how you will write? Okay. So cos beta I want na. So what I will do, sine beta is there. So directly I can write cos beta equals to under root 1 minus sine square beta. So 1 minus sine square beta value will be, sine square beta value is sine square theta divided by n square. This is there. So this is the value of the cos beta that I will be substituting in the displacement equation, that is equation number 1. Let's suppose this is equation 1, right? Equation 1 it is there. So let me write with different color here. Right, so let us write it here. From equation 1. So x value equals to L plus R. L plus R minus L cos beta. Okay, L cos beta. Cos beta value is this one. 1 minus sine square theta by n square. Right, and remaining part is what? R cos theta plus R cos theta. Right. Now the complete equation of this x is in terms of theta, and all other parameter is what? Constant. Only variable here in this equation is what? Theta. Based on the value of theta, I will be getting this x value, or based on the value of x, I will be getting theta also. So that's what our intention here, to connect input motion with the output motion, right? So that is what we are getting here. But what I will do, I will just simplify this equation little bit more, right? So that we will have a fine equation that we can remember also. So L plus R, okay, it is there. So what I will do, see, this is R and R cos theta, but minus R cos theta it will be there. So R minus R cos theta, okay, one side, then plus L minus L into under root 1 minus sine square theta by n square. Let's suppose if I take the LCM, it will be n square minus sine square theta, right, divided by n square. Okay, fine. So this x value, R minus R cos theta plus L, and n square will come outside because it is square, so finally it will be L by n, and under root n square minus sin square theta. Now what I will do here, okay, so now L by n, as n value equals to L by r, so this L by n becomes r only, right, because n value is L by r. So let's suppose if I take r common here, it will become 1 minus cos theta plus this is L, which can be written as n by r. Okay, let us simply write L as it. Let us write L only, no issue. But this L by n becomes r, and here it is n square minus sin square theta. Okay, correct. Now if I take r common from here, so this x value will be what? R I am taking common from the entire equation, so 1 minus cos theta it is. 1 minus cos theta it is. Right, plus L by r becomes what? N. Okay, and it will be as it is because r I have taken common, so n square minus sin square theta, right, like this. So bracket close here. So this is what the relation of the displacement in terms of theta. This is very, very important relation, guys. Very, very important relation. Right, this is very important relation. Why it is important? See, please understand. Here you can directly relate x with the theta. Now let's suppose they have given the x value, but they have not given the theta value. So in that case, theta can be calculated with this equation. Let's suppose they given x value as 25% of the stroke. They have given displacement of the slider as 25% of the stroke. 25% of the stroke means what? Stroke is 2r, and 25% of 2r you have to take. And that value, if you put it here, directly theta you will be able to get. And theta is what? The rotation of the crank. Theta is the rotation of the crank, right? So that's what we can calculate from this relation. So that's why this is very, very important. Okay. Fine. Now, so as we have calculated the displacement, now next parameter that we need to calculate here is the velocity of the slider. Okay. Now, next is the velocity of the slider. Velocity of the slider. Okay, now see, velocity of the slider will be v equals to, let's suppose write vs, will be equals to dx by dt, right? Now x is a function of theta, so what I will do, dx d theta, dx by d theta multiplied by d theta by dt. Is that clear? So because x was the function of theta, so that's why dx by d theta I will do. And what is d theta by dt? It is the rotation of the crank, angular velocity of the crank. Because theta is the rotation of the crank, so d theta by dt becomes what? Angular velocity of the crank, right? So this will be coming like this, vs equals to omega of the crank multiplied by dx by d theta. Now dx already, x value is already there. So just we need to differentiate with respect to theta, and we'll get the answer of velocity here. Okay, so let's do the differentiation part here. Omega is there already outside, and what we need to do, we need to differentiate. Now if I differentiate, please understand, r again constant, it will come outside, cos theta differentiation minus sin theta, so plus sin theta it will be there, and differentiation 0. Now differentiation of this one, under root differentiation, how you will do it, 1 upon 2 into under root same function, and differentiation of this function which is there inside the square root. So n square again constant, no differentiation will be there, 0. Sin square theta differentiation will be what, 2 sin theta cos theta, which means sin 2 theta it is there. So finally if I solve here, you will be getting omega into r sin theta plus, okay, because it is minus sign is there, so that's why minus sign will get cancelled out, because this minus sign will get cancelled out when I differentiate this one. Okay, so remember, so don't be confused why I've written in the differentiation positive, because that negative sign will get cancelled out if I do the differentiation of this square root. Okay, plus it will be there sin 2 theta divided by 2 into under root n square n square sin square theta, right? This is the relation. So omega into r in the bracket sin theta plus sin 2 theta divided by 2 into n square minus sin square theta. Now this is what the exact formula. Now let's suppose one simplification if I do here, r omega sin theta plus sin 2 theta divided by 2. Let's suppose n I have taken common, n square I have taken outside of the square root, so obviously n will be coming. Shubham Kumar, yes, hi Shubham Kumar. So if I take n square value outside of the square root, understand this point, so what will be there, 2 into n, and in the square root, okay, in the square root what will be there, 1 minus sin square theta divided by n square. So this relation will be there. Now very important point, a very good evening Shubham Kumar, very good evening. Now very important point is n value is what, large here. Why it is large? Usually connecting rod length will be more compared to the crank, right? So that's why n value is large. So if I do n square, it will be more having large magnitude. So n square value is the large value, right? Okay, and this sin square theta, first of all sin theta value, sin theta is a less than 1. Now if I do the square, it will become what, more less value. So this is less. So what I want to say here is, this sin square theta divided by n square can be neglected. So once it is neglected, the simplified formula or the approx formula will be what, r omega sin theta plus sin 2 theta divided by 2n only, because when it is neglected, under root 1 will be what, 1 only. So our simplified formula here will be r into omega sin theta sin 2 theta divided by 2n. This is what the formula of the velocity of slider. I hope it is clear, and you will see there are a lot of question has been asked from this particular formula. Now remember, in order to apply this formula, we need to know the theta value, we need to know the rotation of the crank. But let's suppose rotation of crank is not given in some cases, which might they can ask in the gate examination. I'm telling you, if they have not given theta, then how we will solve it? So definitely some information they will give. What kind of information they will give? They will give displacement of the slider. They will tell slider is at this particular position from the IDC. For example, they have given this x value. Okay, this x value is what given in the question. Now if x value is given, from that x value I can calculate the theta using this relation. Using this relation, if x value is given, I can calculate theta. Once theta is calculated, then easily I can calculate the velocity also. So the main point here is, if we have the theta value, we can use it. If we don't have the theta value, we need to try everything to calculate theta value, right? Without theta value, we cannot calculate the velocity of slider. I hope it is clear now, right? Now, next part is acceleration of the slider. Okay, next part here is acceleration of the slider. Okay, next write down acceleration of slider. From this also the question has been asked. Acceleration of the slider. Right? So I will be using the approx formula here. Okay, what is the approx formula? This one. So acceleration dv by dt. Again, velocity is a function of theta, so dv by d theta multiplied by d theta by dt. So d theta by dt, again angular velocity of the crank, right? So what I need to do, dv by d theta. Now if I see velocity formula, r omega constant, sin theta differentiation will be cos theta, sin 2 theta differentiation will be cos 2 theta and 2. That 2 will cancel out with this denominator 2. So cos 2 theta divided by n, it will be there only, right? So acceleration of slider will be r omega square, because already one omega is there and in the velocity formula already omega is there, right? So r omega square cos theta plus cos 2 theta divided by n. This is the formula we are having for acceleration of slider. Now, two important points that we need to remember regarding the velocity and acceleration of slider. If I ask you at where the velocity of slider will be 0, what would be your answer? At which location velocity of slider is 0? Dead centers. That's why it is called as dead center, because at that point slider velocity becomes 0, right? So important point that we need to remember here is velocity of a slider becomes 0 at the dead centers, but acceleration is maximum at the dead center only, right? Because if you put theta value 0 here, you will get maximum acceleration. Okay, so this thing you should remember always. Very, very important part, right? So dead centers velocity is 0, right? At dead center velocity is 0, fine, but at dead center acceleration is going to be what? Maximum. This point you should remember. Now velocity of slider and velocity of acceleration of slider we have calculated, but next thing is what? Angular velocity of connecting rod, angular acceleration of the connecting rod. This is also important, and this part in the GATE examination they have never touched. They have not asked any single question regarding the connecting rod till now. They didn't ask the velocity of connecting rod, they didn't ask the acceleration, angular acceleration of the connecting rod. So these kind of relations they have not asked, right? So let us discuss that part also, okay? And if it comes, it will be very helpful for you, like you will be easily able to solve the question if you remember the relations directly. Now, but how I will be doing? See, as I equated this L vertical components using this connecting rod and the crank, that relation I am going to use. So let us write angular velocity of connecting rod. angular velocity of connecting rod. Okay, now, so the relation that I have to use here is L sin beta equals to R sin theta. R sin theta. So let's differentiate this equation with respect to dt, okay, dt time on both the sides. So on differentiating this equation on both the sides, okay, so let us check what we'll be getting here, right? So this will be L as it is, sin beta differentiation will be cos beta, and beta differentiation d beta by dt equals to R sin theta differentiation cos theta multiplied by d theta by dt. Now, angular velocity of connecting rod. Okay, so first of all, you need to remember angular velocity of connecting rod is nothing but d beta by dt. Right? Why is it so? See, rate of change of this beta angle will give us the angular velocity of connecting rod, right? Because connecting rod is what rotating here. So this beta is what the angle that represents the rotation of the connecting rod. So rate of change of this beta angle will give us the angular velocity of the connecting rod, right? Okay. So here d beta by dt. So let us write d beta by dt. Okay, as omega of crank, omega of connecting rod, sorry, omega of crank is d theta by dt. So simply write omega as it is. If omega I have written, it is what? The omega of crank. Omega of connecting rod with CR I have mentioned here. Okay. Now this is cos theta divided by cos beta, right? And it is what? R. R is there already, and divided by length L. So L divided by R is what? N. So here we can write further. Omega of connecting rod will be equals to omega by n. Omega by n, right? And this cos theta divided by cos beta. Cos theta divided by cos beta, right? This is there. Okay, fine. So omega, that is angular velocity of crank here, divided by n into cos theta divided by cos beta. Now cos beta I can replace because I want the answer in terms of theta, let's suppose. So I will replace cos beta. How I will replace? See, this is cos theta. Cos beta will be replaced by under root 1 minus sin square beta, like this. Now sin square beta value initially we have calculated, if you remember. Sin beta value is sin theta divided by n. So here I will be putting that value. Okay. This is sin square theta divided by n square, like this. Sin square theta divided by n square. This is what the relation we are having. Fine. Now again, as n square value will be large, sin square theta value will be less. So we can basically ignore this sin square theta divided by n square theta, and we can write angular velocity of crank directly. If I am neglecting this part, see, this is the exact formula. But if I am neglecting this sin square theta by n square, I can write omega into cos theta divided by n as the angular velocity of the connecting rod. So in the next page, if I am writing this thing, see. So the logic already we have discussed. neglecting so omega of connecting rod, omega cos theta, omega cos theta by n, like this. So this is what the relation we are getting. Done? Is it clear, everyone? So please note it down this part quickly. Omega cos theta divided by n. So important note points were: at dead center slider velocity is 0, but at dead center acceleration is maximum. Right? So this is the important keywords, important points in this analysis you need to remember, right? So as I've calculated angular velocity of connecting rod, similarly you can calculate angular acceleration of connecting rod. So for that, what you need to do, just differentiate this omega of connecting rod with respect to time. You will get the answer of angular acceleration as well. But again, first with respect to d theta you have to differentiate with respect to theta, and then d theta by dt you need to multiply. So we will get the answer of angular acceleration of connecting rod also. That part I will leave it to you. Okay, that is very easy. Just differentiate this angular velocity of connecting rod with respect to time. You will get angular acceleration of connecting rod as well. So if question comes, directly you can use this relation. Now coming to the previous year question part. Okay, so let us discuss the previous year questions, guys. So this is the very first problem. Okay, 2017 1 mark question, very easy problem. 2017 1 mark question they have asked, very easy problem. Okay, so I want everyone to solve it quickly. Okay, so this question doesn't need that much time, so please solve it fast. Everyone solve this question fast. So they have given a slider crank mechanism, length of crank and connecting rod they have mentioned. Okay, so let us write the given data first of all. Okay, length of crank, that is R value, and connecting rod value is 160 mm. Fine. The crank is rotating with an angular velocity of 10 radian per second. So omega value they have given. Okay, simply whenever I am writing omega, it is omega of the crank. Fine. Okay. In counterclockwise direction. Okay, fine. The magnitude of the linear velocity of the piston, that is what slider they are asking. Just now we have written a formula, right? Formula is R omega sin theta plus sin 2 theta divided by n. This is there. Now what is the theta value here? So just see the diagram here. Theta is the angle of crank, angle of rotation of the crank. The angle they have provided here is 90 degree. So if I put 90 here, sin 2 into theta, that is sin 180, that becomes 0. So this part 0, sin 90 is what? 1. So directly R into omega if I do, I will get the answer. Is it clear to everyone? Right? Angle of crank here is 90 degree. So sin 2 theta becomes what? Sin 180 degree. Sin 180 degree means 0 value. So this is 0. Now coming to sin theta, sin 90 degree, 1. R into omega, R value is 100 mm, that is 0.1. Omega is what? 10 radian per second. So what will be your answer? Please tell me your answer. Or any calculator or any calculation is required here? No, very easy, straightforward. That's why it is 1 mark question. Immediately you will see angle 90 degree, directly you will write, your answer will come out to be simply 1 meter per second. Because this is 0.1 meter, 0.1 multiplied by 10, you will get 1 meter per second answer. Okay, very simple problem they have asked, very simple. Now moving to the next problem, this one. again. They are asking the magnitude of angular velocity of the crank. Now this time something different they are asking. Angular velocity of the crank. But what they have given? They have given the velocity of the slider. Velocity of the slider is given here. So then omega we can calculate. Okay, let's try everyone and tell me your answers. And very important information in the question they have given regarding at a instant when connecting rod is perpendicular to the crank. Connecting rod is perpendicular to the crank, they have mentioned. Right? This is the important information. So let us draw the diagram here, connecting rod perpendicular to the crank. So a rough diagram we can draw. So this is the rough diagram I can mention here. Okay, now see. This is the 90 degree they have given, right? So this is the crank. Now length of the crank and connecting rod 3 and 4 meters. So this is 3 meter. This is 4 meter. Like this they have mentioned. Okay, so this is 90 degree. Can I calculate the angle theta here? Because theta is what required. Okay, now see. Velocity of slider is equals to r into omega sine theta plus sine 2 theta divided by 2n. So this formula will be what? Will be using when theta value is what known. But how to calculate theta? Simple trigonometry you need to apply. Na? This theta I want. Rotation of the crank. This rotation theta value I want to know. Simple trigonometry we can apply. In front of theta, this is what perpendicular, this is what base. So tan theta is equals to perpendicular upon base. So in front of angle, this is what? Perpendicular 4 divided by 3. From this theta value I will calculate, and that theta I will put because velocity of slider is given. Velocity of slider is 1 meter per second. It is given. Theta we will calculate from this trigonometry, basic trigonometry we will be using, and then finally omega we can easily calculate. We will get the answer of omega. Right? So this is again a very easy problem. Right? But here a little bit more calculation is required. That's why it is 2-mark question. Previous one like very easy. For that even you don't need to pick the calculator. No need of calculator in the previous problem. But here in this case, definitely calculator requirement is there because we need to calculate theta. Okay. So please everyone do it and tell me your answers. Theta value approximately 53.13. So you can cross check your answers as well. 53.13 degree. Thus theta I will put here. Velocity of slider already 1 meter per second given. This 1 meter per second I will put. Theta value 53.13 I will put. R already given. R value is 3 meter. So omega you will be able to get. Okay. Omega value you will be easily getting the answer from this equation. Okay. So that basic calculations we need to do, right? 0.287 will be the answer. 0.287 radian per second. This will be the answer here. Now moving to the next one more problem. Yes, this one. So let us try this problem also. Again 2015, 2 marks. Now in the question what they are asking, again single cylinder crank mechanism they have given. Length of the crank and connecting rod are equal. This is important information. Crank rotates with a uniform angular speed of 14 radian per second. First of all, connecting rod and the crank length is equal. Omega of crank they have mentioned as 14 radian per second. Okay. Now what they have given, the crank length is, let's suppose 300 mm they have given. The maximum acceleration of the slider. Three hundred mm as a crank length they have given, and obviously it will be equals to connecting rod as it is given in the question. The maximum acceleration they are asking. Now as I told you, under what condition acceleration will be maximum? Tell me, under what condition acceleration is going to be what? Maximum. See, acceleration of slider formula is R omega square. Cos theta plus cos 2 theta divided by n. This is the formula we are having, right? Okay, so R omega square in the bracket cos theta plus cos 2 theta divided by n. This is the formula. Now when it is going to be what? Maximum. Under what situation this value is going to become maximum? When theta is what? 0. At the dead centers, the acceleration of slider is going to become maximum, but the velocity of slider is 0 at dead centers. That's why inner dead center, outer dead center. At dead centers, for a moment piston will stop. That's why velocity is 0. So it will get maximum when theta value 0. If I put theta value 0, okay, R value crank length 0.3 into omega square. Omega square is what? 14 square. Right. Now cos theta value 1. Cos 2 theta value again 1, and n value is also 1 because L and R is equal. So from this you will get the answer. From this you will be getting the answer very easily. $117.6 will be the final answer here. $117.6 meter per second square is the maximum acceleration that we are getting here. So this is what the answer of slider acceleration, which is what? Maximum. Right. So basically we have put theta value as 0 degree. Done. So this is the question. Now there is, I think, one more question here. Yes, this one also. So I will give you as a homework. Okay, this question, consider this as a homework here, right? So next class we are going to discuss this question also. First we will be discussing the solution of this question. Then after that, dynamic analysis of single slider crank mechanism, where a very important relation, that is turning moment. What is the torque that is going to act on the crank? We will be calculating. That is very important parameter here, and same discussion we will continue in the flywheel chapter also, because that turning moment formula is what going to use in the flywheel chapter, right? So after the dynamic analysis of single slider crank mechanism, that is on tomorrow's class I will discuss, and after that flywheel is going to start, right? And I think there will be 3 to 4 sessions I am going to take in flywheel, and after that gears we will be discussing. So first class will be on the introduction of the gears, like different types of gears that we need to know, all basic informations, fundamental part, and after that directly we will be starting the gear train, because gear train is the most important part for the gate examination. First I told you the velocity analysis of simple mechanism. Second part is what? Gear train, and mostly epicyclic gear train they are asking questions. And this year the gear train question was come. Okay, gear train question came in the examination 2024 gate examination, but in that they have drawn a line diagram. And I've seen, like I've told also multiple times, line diagram is what? Very easy. A few years back also there was one question they have asked line diagram, and this year that is the second time they have asked. So we just need to know how to represent a gear in a line diagram, right? So that is what required. So all those parts we are going to discuss, and after that gyroscope and balancing also, because there was a request from your side only that reciprocating balancing of reciprocating parts you want to discuss. So we'll be completing all important parts, right? So if you have any doubt in any of the topic of theory of machine, you can mention in the comment box. We will definitely bring one lecture on that particular topic, right? So as this is a foundation course, okay, so our intention in this particular lecture is what? To just discuss the basic fundamental parts, right? And definitely in the upcoming sessions we are going to discuss more and more questions also, right? So thank you so much for this particular session. Tomorrow we will be discussing dynamic analysis of single threaded crank mechanism. Thank you so much, guys.